Hello everyone, welcome back again. I am Divosh from the Viewers channel. Our today's video will be we will make a custom CNN model for image classification. So let's start the video. So for this video I have also right now 60 images and this magic file. For this I will have to go in my Google Drive and here I will make a folder. I think I will make the name custom CNN and let's create the folder. So in this folder I will upload my dataset which is in the zip file in my desktop. So, image classification. It will take some time. Okay, now I will open the Google Colab and until image augmentation I will copy and paste the code which I have done in my previous video. So in the previous video you will learn the full details of this, but in this video I will show you just copy and paste and some helpful description. Okay, so this is the collab file which I have worked on my previous video. So I have copy and paste the code here. After running this, Colab will ask for your permission to access Google Drive. Just click the link, login. Once it mounted successfully, we will be able to read and write files directly from Drive, which is super helpful for loading dataset and saving models later on. Okay, perfect. Now I will copy the code of unzip file. By writing this code, I can unzip my dataset to a folder. For this reason, I have to change my path only. So I am changing the folder, which will be custom CNL. Okay. Same thing, I will have to change here also. Custom CNL. Perfect. This command will extract the contents of the image classification.zip file. Now, here you can see the folder is here. Now let's import the necessary libraries we will be using throughout our project. So from my previous collab file, I will copy the code. So we begin with NumPy, which is crucial for handling errors. TensorFlow for building and training our neural networks. OpenCV for processing image, which helps us manage data. That's it. Now I am trying to show you the amount of images. For that reason I have to just change my location path. That's it. Now just number of image items, which will show me the number of images. Okay, I have found 60 images for each category. Next, we want to create a new directory where we will store the augmented dataset. We are augmenting our dataset because we have only 60 images, which is very low. That's why 60 images in each category. So I want some augmented images for my project. Okay, the folder, let's refresh it. Okay, augment dataset folder is created here. Now in my augment dataset folder, I will have to create my 5 categories folder. That's why I have copied the code and just paste it. If you have any confusion, you will just see the first video of this channel. You will get details information there. Okay, so let's see. In my augmented dataset folder, I have 5 categories of folder. Sorry. Okay, so this is my augment dataset code. So I am copied the code and just paste it. I have already told you in my previous video that we have to just change our path. Here I want to generate 200 images. That's why I write 200 here. And just I need to change my path. So you guys also change your path in this part of the code. Okay, so all are okay now. So as from shoes I am augmenting my image. I have to do all these things for all categories. After shoes I have to write plastic here. Okay, now plastic. I hope you guys are understanding this video also. If you have any problem, I repeat again that you need to watch the previous video. And I am augmenting again in this video because my dataset is very low. So when you have a low size of dataset, you just need to augment the image and then you will run the dataset in your custom CNN model. Okay, now plots. Let's run it. Okay, so the final part will be battery. This process allows us to create new variations of the original images, expanding the datasets and making it more diverse. So right now, in this section of the code, we want to check how many images we have in this each category after performing the augmentation. So I copied the code and just paste it. Now we want to see the number of augmented images. So just type the code or just copy it from my previous bullet file. So okay, so we can see in each category we have 200 of images. So from now on I will make new movement of this video. So now I will create 2 folders for training and validation. So my original dataset now will be augmented dataset. For this now I am creating another folder. So let's copy the code from my previous part. And here my original dataset will be augmented dataset. That's why I wrote it here. And I will create a new folder for training and validation. That's why I am making a new folder in custom CNN folder. So let's run it and see it on my Google Drive. Here I can see. Let's refresh it again. In my custom CNN folder, I see new folder is created. So in this new folder, I will be opening 2 folders. One is train folder and another one is validation folder. So let me write it for you. how to open the folder. Right now I hope that you already learned how to create folder in Google Colab file. Okay, let's make some note here. Create two folders. Okay, let me write under new folder. Okay, so let me check. In my new folder, let me check. I have already found train and validation folder. Now under train folder, I am creating another 5 folders in the same way what we did in previously. Just path will be changed, and we also create another 5 folders in the same way as in the validation folder. So let me write the note here. So now I will create 5 folders here. This is the way to create a folder. So okay, my battery folder is done. So I need to write another 4 folder. So I am just copying and pasting the battery folder so that I can only change the name of the folder. So I will change here clothes. Okay, here also I need to change clothes. CLOTHES. Okay, I think it's fine. Now let me check another folder name is after clothes. Okay, pepper. So I will write here pepper. Let me change in every part of this code. I hope after seeing this video, your thesis or any kinds of final year project with the topic of image processing will be clear for you, and you can do some research by making custom CNN. Okay, it's the last part. Shoes. Okay, let's make another note here. I will need to make another 5 folders in the same way, but on the validation folder. Let me copy the code and paste it, but I need to change here validation. Okay, for your information, I also did my research on my final year when I was studying in Breck University. My research topic was waste classification, and I almost researched 8 categories. You can see my paper. I will keep the link in my video description, and I will make another video by researching my research paper so that you can easily understand about image processing. And I have a plan, as it is only based on code, so I want to make a PowerPoint video for you guys so that you can understand a full CNN, which layer works in which position of the code and which what can I say, which necessary libraries are needed, so I can give you a short description in my next video. Okay, I hope my folder creation is done. So done. Let's see. In my new folder, I'll go to validation. Okay, I will find 5 folders, and in my training, okay, here is also 5 folders. It's done. Now I want to break my dataset in 80% in training folder and 20% to validation folder. For this I am using a function. I have already copied the code and paste here. Okay, it's done. Now I will create directories where battery directory is the path where the augmented battery images are stored, and training directory is the path where training set for battery images will be stored, and valid battery path where validation set for battery images will be stored. So like this I will create other file. So let me first change the path of this code. After changing the path, I'll just copy paste and change the name of the folder. That will be okay for creating directory. Okay, so here everything is fine. So for training and for validation, this is the folder. So right now I just copied it and paste it, and just I'll change the folder name. So here it will be clothes. Clothes here. Let me copy it again. After that comes pepper. So I need to write pepper here. Another two needs to be written. Okay, it will be plastic. Okay, now the last one, shoes. I repeat, if you have a large dataset, you don't need to augment your dataset. You just keep your main dataset and just do it after creating train and validation folder. Okay, so done. Now here I will import a library which is really useful for splitting the dataset. So the library is from Shootil import copy file. This one. This is the split size. So I want, okay, there is some mistake is going on. So my directory dir needs to be changed. Okay. So I need to just copy it from here, just only this directory dir. Only this part. Okay. Okay. Done. So it's done. So what I am saying that I can use 0.70, 0.60, but for this video I am using 80% to 20%, which means 80% of data will go to training folder and 20% of data will go to validation folder. It can be used previously, but for easy explanation I am using it separately. You can use it the code which I copied previously before doing the directory folder. You can use it there, but for easy explanation I am using it here. So let me change the folder name. Pepper. After pepper it will be plastic. So plastic here, plastic, plastic. So and it will be shoes. Okay, done. Now just run the code. Oh, I made a mistake. Let's see. Battery dir not found. Okay, okay, let me check what is the code. Oh, I see. After running the, yeah, I think it is after running the battery dir, I didn't run the code. Now it will work perfectly, I hope. Yeah, it is working. I didn't change. I didn't run the code after changing the directory dir. That's why I found the red dot. Okay. Now for visualizing the distribution of different classes in our training dataset, first we import, necessary libraries, matplotlib for plotting the data, seaborn for enhancing visualization, and Image to read the images. We also use pathlib to manage file paths easily. This visualization data will help you to make figures in your thesis paper. So let me run it. Yeah, so we can see the visualization of data where we can see 164 images are in the training dataset. Let me help you by calculating. So we have 200 images overall in each category. So, and let me multiply it with 0.8. So 160 images in each category. Okay. If you, this is optional. If you need it, you can write the code. I suggest you to write this code. But if you don't need it, you just want to see in another way, not visualization, then write this code, and you can see 160 images are showing in the code. Let me run it. Okay, so in each category we are finding 160 images. This is also optional. Okay, right now I will copy this to see the another part of visualization. Sorry again. So now it will be validation folder. So here validation. Okay, let me write it. Okay, so this is 40. 160 plus 40 is equal to 200. So I hope you are learning very well. Let's paste it and just change the name of the folder. Now we will work on our model. Now we want to see the whole images, which means I want to see the full image list. For that reason, image data generator, this is used for real-time data. Adam is the popular optimization. Early stopping is the callback to monitor the validation loss during training. And model checkpoint, this callback saves the model at regular intervals. Okay, so image weight is 150, image height is 150, and batch size, this refers to the number of images that will be passed through the model at once during training. A larger batch size can speed up training because it processes more images simultaneously. Setting the batch size to 128 is the balance between memory usage and training speed. Now we are preparing for the training data for our model using the image data generator. We are using image data generator to prepare and augment our training images for the model. So here we can see 800 images belonging to 5 classes. Now we will do the same as for validation. Let me copy the code, just paste it here. Okay, just I will change the validation of, again mistaking, caps lock is on validation. Okay, let me run the code. Oh, there is some mistake again because it is showing 800 images, but it will show only, I guess, 200 images. So okay, it will be validation dataset and validation generator. Again, okay, fine. There is also need to be changed. This is validation dataset and here validation DIL. I hope now it will be okay. Okay, so 200 images belonging to 5 classes. So in this part of code, we are importing essential components to build a convolutional neural network, which means CNN. So This is the layer of the CNN con 2D. This layer performs convolutional operations to extract features from images. Maxpool 2D reduces the spatial dimensions of the image, helping to downsample the image while retaining essential features. uh, I will make a details video of this by describing which layer works, but for this video you need to remember flatten layer, dropout layer, max pull layer, batch normalization, conv layer. These are the layer which is used for to develop a custom CNN model. And reduce LR on play 2. These callbacks adjust the learning rate when the model's performance dropped, helping to avoid overfitting and speeding up the convergence. Okay, that's why we used reduce LR here. And here you can see minimum LR is 0.00000001. This sets a minimum learning rate to prevent it. Okay, so now I am typing the model. So for this model I will have to use sequential layer, dense layer, con 2D layer, not sequential layer. This is a sequential model. This is a linear stack of layers. It's one of the most commonly used ways to define a neural network in Keras. Each layer has weights that correspond to the input and output dimensions of the previous layer. And then comes con 2D. This is a con 2D convolutional layer, which is fundamental in a convolutional neural network. It applies filter to the input image or features map to detect pattern like edges, textures, etc. Max pooling layer reduces the spatial dimensions of the input features map. Now I am given the all kinds of layer here. You just need to change here. First I use 32, then 64, then 128. I used max pool layer. Okay, then I use batch normalization. So right now I want to make another parts of layer, and here I will use 256. For your research, this part is very essential because this is your model. So you need to change or update your model to find better accuracy. That's why this is called research, and you need to careful so that which model will work in your dataset. Here I am giving dropout layer. Okay, so and at last I will giving flatten layer, and here I can use 256, 512 in dense, but here I am using 128, and activation is softmax. And as I have 5 categories of for images, that's why I will use 5. This is important. This is a random model. I don't know whether it will work good or not. I am using initial learning rate here, and I am using optimizer, which is Adam. That's it. You just need to write it, and this is your model. And if you want to visualize your model, just write model.summary. It. You can use this summary in your paper also. This will give you a clear-cut idea about your model. I repeat, this is a random model. I don't know how it will work on my dataset. This is just for showing you how you can do it. So now I am thinking 30, yeah, I think 30 epoch will be better. Otherwise video will be so long. So, and then just run our model and that's it. It will take a lot of time. I will show you first three epoch and then just pause the video, and sometimes I will come and give you update what is going on. So let's see. As this is going on, I want to say again you that after doing the all procedure, when you come to build your model, if you have a clear-cut idea of CNN model, how it works, by doing a lot of research you can update your model. Otherwise you will not find a good result like this video. I think I will find 65 to 70% accuracy in this video or less than that. Let's see how it will work, but it is not enough. On my research I got 97% of accuracy in the 8 categories, and I have almost 32,000 of dataset. So you need to understand the model and then apply it. But this is the full procedure. Okay, my first epoch has given me 30% of accuracy, which is not bad. And the second epoch is almost, I think, 51%, no, 50% of accuracy giving, which is showing me. This is something you will enjoy. You will build a lot of model and you will see which model works better for your dataset, and then you finalize your best model and you will submit to your professor for your research or for your conference paper. I hope you guys like this video. It will be really necessary for your final year thesis. On my thesis part, I didn't get a full video. I had to work a lot. That's why I thought that I need to make a video of this topic. So here I am seeing that almost 50% of accuracy has come after the 3 epoch. So I think after this epoch I will pause the video and I will come again to give you an update. Okay, so 3 epoch is done, 51% accuracy has come. Okay, so after 10 epoch I have got 57% accuracy. So my assumption is correct. This model will not go above 65% of accuracy. And here you can see reduce LR. When the accuracy is not doing well, it just reduce the learning rate. Okay, here I got 60% after 12 epoch. Okay, so after 30 epoch, in my 70 15 epoch I got the highest accuracy of 63%, so which is not bad at all for this video. And my last epoch is showing that it will not. So this is the model you need to change to get better accuracy, and then run it, and you can change your epoch also. Yeah, so what I can see, what I am saying that from my last epoch I am saying that it is 58%, so I can say that my highest accuracy which I have got on 17 epoch, which is 63 point something percent, so that will be my result for this model. So now I want to let me finish the epoch. It will take some time, I guess. Okay, take 32 minutes. Okay, so now I want to visualize the result here, so that's why this is the training accuracy and validation accuracy. This is the what can I say, you can use this figure also. Now I want to visualize the loss, so I will just copy and paste the code. Okay, so this is my validation part. So that's all for today. I hope you guys enjoyed this video. So if you enjoyed this video, please like and subscribe my YouTube channel. I hope in future you will get a lot of videos from this channel. So thank you everyone.